T-minus 1 minute and continuing to count. A water deluge system now has been turned on, activated at the pad area. Pressurization taking place now, the various tanks aboard the vehicle being pressurized. Switching to internal power. All stages switching now to internal power. All propellant tanks being pressurized. Count continuing smoothly. The water at the pad covering the flame deflectors. Now we've passed the 30-second mark. Water also will be coming on to the decks of the mobile launcher at the ignition point. T-minus 20 seconds. And the countdown continues to go smoothly. Guidance release. T-minus 13, 12, 11, 10, 9, 8. We have ignition sequence has started. 6, 5, 4, 3, 2, 1, 0. And we have a liftoff. The Skylab lifting off the pad now, moving up. Skylab has cleared the tower.
Houston is now controlling. 18 seconds, pitch and roll program started. Saturn now maneuvering to its proper flight path attitude. Mark 25 seconds. 8 seconds. 35 seconds, 1 nautical mile in altitude, looking good. Range safety, give Saturn a green, we've cleared the beach. 50 seconds, 2.5 nautical miles in altitude. Ground display data shows good stable thrust on all 5 engines. Coming up now in 1 minute. Mark 1 minute. 1 minute, 5 seconds, 4 nautical miles in altitude. Coming up now in period of maximum aerodynamic pressure on the vehicle. 1 minute, 10 seconds. Roll program complete. Pitch profile still in progress. 1 minute, 20 seconds, 7 nautical miles in altitude. Velocity now reading 2,500 feet per second. 1 minute, 30 seconds, pass through max Q, still looking good. Saturn now at 11 nautical miles in altitude, 5 nautical miles downrange. Velocity now reading 3,300 feet per second. 25 seconds, all sources continuing to look good. 6 seconds, 20 nautical miles in altitude. On center engine shutdown. Shutdown on time, reports booster system is engineer. 2 minutes 33 seconds, 40 nautical miles in altitude, standing by now for first stage shutdown. Stage shutdown, good separation on time, good ignition on the 5 second stage engines. Saturn now 56 nautical miles in altitude, 64 nautical miles downrange, 9,300 feet per second now reading the velocity. The huge first stage falling away now out of business. 3 minutes 10 seconds, coming up on skirt set. Stage has jettisoned on schedule, the 11,400 pound ring dropping away now from the second stage engines. All sources continuing to look good. At 3 minutes 33 seconds, the 2 habitability area vent valves are now opened, reports booster, bleeding off nitrogen stored on board pre-launch. We now show Saturn 88 nautical miles in altitude, 124 nautical miles downrange, velocity now reading 11,000 feet per second. Looking good, reports booster, coming up on 4 minutes, mark 4 minutes. Minus 10 seconds. Saturn now 108 nautical miles in altitude, 170 nautical miles downrange. Velocity now reading 11,244 feet per second. Minus 30 seconds. Still looking at 5 good second stage engines performing as advertised. Minutes 55 seconds. The multiple docking adapter vent valves have closed now at 1.3 pounds per square inch. 23 nautical miles in altitude, 268 nautical miles downrange. Velocity now reads 12,634 feet per second. Center time, good sustained thrust on the remaining 4 engines. They burn for about 4 more minutes. The timing in this event quite different from a probe, but this Saturn is carrying a much lighter payload orbit. The shutdown time to when Saturn is beginning to pitch over for more straight and level flying rather than climbing for altitude. We now show Saturn at 160 nautical miles in altitude, 328 nautical miles downrange.
This is Skylab Control. 2 hours, 41 minutes. Ground elapsed time in the mission of Skylab I. Skylab space station now in orbit, coming up on the Honeysuckle, Australia tracking station. Still some doubt in the minds of flight controllers here in mission control as to whether the main solar panels on the workshop have indeed deployed. They've had no confirmation on the ground from telemetry that this is the case. The solar panels on the telescope mount have deployed normally. Also, the micrometeoroid shield around the workshop has partially deployed. The large wings, 3 sections of solar panels on each wing, one on each side of the workshop, generate anywhere from 51 to 125 volts depending on the sun angle at the time. This power goes through chargers, which in turn keep storage batteries in the workshop built up to supply power throughout the mission. Half of each orbit approximately is in darkness when no power can be generated by the solar panels. The 2 solar panel wings are deployed out to the side of the workshop, and each panel on the wings operates on similar to a scissors action, spring-loaded to extend the panels. Be getting data now through Honeysuckle. We'll stand by for comments to the flight director from the flight controllers who are concerned with the workshop electrical power system, and relay this information as it no change reported in the solar panel wing status. This is Skylab Control, 4 hours, 14 minutes, ground elapsed time, the Skylab space station mission. Here in the control center, the problems associated with the failure of the Saturn workshop solar panels to deploy are being discussed at some length by management and flight controllers. Preliminary telemetry indications are that there could have been a malfunction with one solar array beam fairing and the meteoroid shield, which could have led to subsequent anomalies. These malfunctions were indicated to have occurred 1 minute and 3 seconds after liftoff based on post-launch examination of telemetry. The planned 28-day mission is not possible without deployment of the workshop main solar panels. Project officials are considering an alternate mission using the command service module power system to augment the limited power supply provided by the Apollo telescope mount solar panels aboard the workshop through a system of managing the 2 power sources for the optimum usage. An announcement will be made as soon as these decisions have been reached. The decision on such an alternate mission is expected to be had by about 9 p.m. Eastern Daylight Time, at which time a news conference will be held at the Cape, and it is expected that Skylab Program Director Bill Schneider will take part. We're starting to get data now through the Honeysuckle Australia tracking station. This is a rather low elevation angle pass of a little over 4 degrees, or approximately, I stand corrected, that 86 degree is the max elevation on this particular pass, almost directly overhead at Honeysuckle. Almost 9 minutes remaining in this pass across the Honeysuckle station. We'll stand by on the Skylab control circuit for the Honeysuckle, followed by Hawaii and the next stateside pass. At 4 hours, 18 minutes ground elapsed time, this is Skylab Control. This is Skylab Control, 1800 hours Greenwich Mean Time. Skylab Space Station now crossing the northeastern coast of France on the 30th revolution. tracked by the Madrid station. Cabin pressure aboard the Skylab workshop is holding between 4.5 to 5 pounds. Internal temperatures by the various sensors range in the low hundreds, that is around 115 to 120 in most locations. At the scientific airlock, the temperature is ranging from 170 to 190 degrees Fahrenheit. External skin temperatures are running between 240 and 300 degrees. Battery temperatures in the power system, electrical power system, are running around 30 to 40 degrees, and sensors on the ATM, Apollo telescope mount solar panels, show temperatures of 90 to 100 degrees. Quiet here in the control center midway through the 12-hour shift. Flight Director Don Putty continuing to direct his team of flight controllers in managing the spacecraft systems. The guidance and attitude control system is still operating normally. We have not been on the thruster attitude control or TAC system since sometime yesterday. The quantities remaining of the gaseous nitrogen used in the TAC system is still hanging at about 82%.
This is Skylab Mission Control at 2 seconds after the hour. Midway through its 58th revolution, the spacecraft is now traveling on a descending node over the Indian Ocean. It is on the dark side of the Earth. At the highest point in its orbit, it is now 237.7 nautical miles above the surface of the Earth. At its lowest point, 235.4 nautical miles. Present speed for the space station is 25,096.6 feet per second. The period of revolution is 1 hour, 33 minutes, 22.3 seconds. Flight Director Donald Putty has requested his guidance and navigation controller to provide him with instructions that will allow the greatest possible conservation of gas used by the thruster attitude control system. While maneuvering required to provide stable temperatures in the orbital workshop section of the space station has used about 24% of the total supply of attitude control gas, the remaining gas is more than double the minimum amount required to conduct all the experiments originally planned for an 8-month period with 3 separate astronaut teams. Nevertheless, flight controllers are taking action to maintain as large an excessive reserve of attitude control fuel as possible. Notes on work that might be done by the first Skylab crew to deploy one of the solar panels that is believed to have stuck when the meteoroid shield was torn off shortly after Monday's launch suggest that the efforts will be made during the first daylight pass of the stand-up EVA. Attempts to deploy one solar wing will be made only if the crew feels that it can be done without difficulty. Because the wing has been on the shadowed part of the space station, the temperature may be too low for the solar panels to move out freely without further assistance, even if obstructions are removed by the astronaut. If the crew does not believe it can free the solar panels, which would provide another 6,000 watts of electrical generating power, engineering photos will be taken for use in planning the following second Skylab manned mission. This is Skylab Mission Control at 2 minutes and 10 seconds after the hour.